All right, mic check, mic check. How do I sound? All right, good, good. Let me get the time to start because I think I'm am I the last one for the day? Oh, no? Go. All right. Got to stay on time anyway. Okay. Hey, good to see everyone. Good to be here at the Hacking with the Homies conference. I believe I've been at each one of them. I think this is the 5th one. I think I've been to all of them, which is pretty cool to say. And I just got to say that, so I just came from the RSA conference. Like literally, I'm 24 hours off of a red eye, coming back from San Francisco at the RSA conference. I was fortunate enough to be able to present there. And I just think it's so important for us to be here to support these kinds of events because the community needs this, right? We need to be promoting the ability of us to be here and to be represented in these types of forums. There's 30,000, probably close to 40,000 people that are out at RSA. There's plenty of black folk out in San Francisco, and that's one thing. But to have this back here in Detroit, I would always just give props to Mac and Jasikia and the whole team for all of the work that they do in putting this on. And I'm just pleased to be able to be here. Who am I? My name is Andrew Cameron. My current role is that I am a senior technologist for IT security at General Motors. But I speak a lot on most things around security. My focus, my specialty is identity and access management. And so let's get a show of hands. Are you familiar with what identity and access management is? Cool, okay. What identity and access management is, for those who are not familiar, is basically the user-facing elements of security and accounts for accessing anything related, digitally in an enterprise. My focus is on enterprise and securing things in the enterprise, and that's why the topic today is about cloud security, about all of you folks as developers, as technologists. You are developing things in the cloud. When the brother was just up doing all of his API development, typically when he's finished developing that, he's pushing that code through a pipeline to be deployed into some Kubernetes cluster somewhere, or he's pushing it to be in some cloud environment somewhere, right? And so with my team, what we do on a daily basis as we work to make sure that those folks who are building things, who are building cool things, are doing it securely. And so there's a whole lot, obviously, that goes into cybersecurity. And I would encourage you, if you're considering career paths, that cybersecurity is here waiting for you. And I think that you won't have to go far to find that there's a lot of opportunities once you can, gain a level of expertise in it, right? It's as with anything in technology, it's not easy to get there, but once you can get there and you can demonstrate some competency, there can be a lot of opportunities there. So I would encourage that from a career perspective, right? So let's get it started. So last year, I actually talked about API security, and I got into some details in terms of what goes into, and so there was a question around how do you protect, like, which HTTP verb is exposed through an API. And my talk last year actually went into that in terms of when you're developing APIs and pushing them out there. The brother's answer was correct in terms of you only expose certain verbs anyway, but you can lock that down a number of different ways. You can lock it down in the infrastructure. You could only allow certain verbs to be requested in the HTTP request. And a lot of the tools that I'm going to be going through today are ways that you can create what we call security policies to enforce those kinds of protections, right? So you're trying to prevent. If you look at the news, you'll see data breaches, data exposure, data leaks, malware attacks that are happening on a regular basis. And being able to secure everything that we build comprehensively is going to be really, really important. And it's important now, it's going to be that way in the future.
Yeah.
So just quickly, as a quick disclaimer, no matter who I work for, no matter who I might represent professionally, what I say here is my opinion. What I give here is guidance, take it for what it's worth. It may be valuable to you, it may not. I don't speak for who I work for, I speak for me. Just keep that in mind as I bring this forward. So I'm going to talk about things like zero trust. I don't know if you heard, probably if you've been in IT for any amount of time, you've heard zero trust architecture, and you've heard that kind of thrown around as a buzzword. I'll get into that. I'll get into cloud infrastructure, right, kind of building things in the cloud, and I'll get into kind of what that means and how, on the security side, we think about securing things in the cloud. I'll bring in how identity management and how doing things like securing single sign-on is really important. And I'll give an example, a couple of demos about that. And then I'll walk through some scenarios through things like securing single sign-on, like what it means to request privilege access and kind of what that means. And also we'll talk about machine identities. You may not be aware that machine identities are extremely prevalent across anything that you build in the cloud. And those are probably the most vulnerable pieces of infrastructure that are out there. If you're committing code to your repos and then you're keeping API keys, if you're keeping API secrets in your code, please stop because the attackers are out there, they're scanning repos, they're getting API keys, and then they're using that to expose, to get data, to do malicious things in your infrastructure. So I'll give an example about how a tool like HashiCorp Terraform can help do that better, right? There's better ways of kind of securing infrastructure with machine identities. Okay, right, so we know the cloud is secure. No, we don't know that. It is secure. Basically, the cloud is just a bunch of tools. It's a technology platform. It gives you the ability to use it securely, but you have to know how to do that, right? You have to know how to take advantage of the tools that are available to you to be able to secure the cloud. And one of the most prevalent guidance around that is zero trust, right? And so zero trust is really built around three primary kind of principles where you basically verify everything, right? So if you are seeing, if you're building things within your company, or if you're building things and deploying them to the cloud, you should get a certain type of authentication that's challenged from you and your platform, right? And I'll get into some advanced ways on how that's happening, but basically, you should always be accessing something based on your identity, and it shouldn't matter that you may be on your company network, or it shouldn't matter that you're coming from home. Wherever you are, you should always be challenged when you're accessing something, and challenged securely. And I'll get into that in some more detail. Things like MFA are mandatory. Whenever you're working in a large enterprise, you must always assume that MFA and strong authentication are required. And there's a thing within Zero Trust, it's called assume breach. And that's just not to say that you live under the expectation that your data is flowing out of your network every day. But what you do want to have in terms of perspective is you want to assume when you set up your security protections that there are ways that you can see your network activity, your API calls, your accesses. You want to be able to see that in a way that to the lowest level of details, that you can monitor that traffic, and you can set alerts around what's happening with your traffic, and to be able to be aware if something suspicious or malicious is happening. And then there's a concept called least privilege. Least privilege means that you only get access to what you need to do your job, and you don't have that access forever. You don't have that access for too long. Basically, you request access to be able to do something. If you're a DevOps engineer, you request access to run your pipeline, to execute your code, and then that access expires, right? Or the access goes away, and now you don't have standing privileges in your environment that can be compromised if they steal your identity, and it can be used to do malicious things in your network. So in terms of kind of how we leverage these concepts a bit more broadly, there's a concept called a signal, and a signal is just, it's a message, right? It's something that tells your infrastructure that you logged into your workstation, or that you push some code into your repo, or there could also be things called risk signals, right? And there could be a message that comes into your environment that says, hey, this person signed in, but the ID that they signed in with has been exposed in a data breach, and we are flagging this as a risky sign-in. All of those are signals that come into your security infrastructure, and it gives you awareness to what's happening on your network. And when you get those signals, you can set policy and take responses when those things happen. If, for example, if we're logging into our OnStar mobile application and your email has been flagged as exposed in a data breach somewhere, you as a customer would want to be aware of that, right? You would want to know that if we saw that your login was risky, we might flag you and say, hey, we think that you might be a risky sign-in. We're going to prompt you for an MFA challenge, right? And you have to go through an MFA execution. So those are the things that on the back end we're setting policies for, right? We're setting, if this, then that kind of policies where we're trying to protect the user and when it comes in the customer situation, but also on an enterprise scenario, we're trying to protect access to enterprise resources, right? To the company jewels, as it were. So in terms of how we look at it, and I talked about risk, when evaluating risk, there's kind of two types of risk. There's the user-facing risk, and there's different signals that come in. So one is called impossible travel, right? So impossible travel is, I'm logging in Detroit at 4 o'clock Eastern, and then our system detects that my account was also used to log in, Kazakhstan in 20 minutes, right? So comparing the logistics of that information, impossible travel, highly likely that that is a compromised account, and we should block the account, or we should throw a MFA challenge to make sure that the user can do an additional validation before we give them access to something. There's also things called device risk, right? And so lots of us, we add browser extensions. In your Chrome browser, you might add this cool extension that you think does something really cool. You have to be careful with that, because those browser extensions in a lot of ways can steal your login information, and it's just exfiltrating your login information to some command and control. And then those folks are using your login credentials to access whatever service and to do malicious things, or to get access to your own personal information, right? So that kind of risk is understood, and there are signals that can be sent back that says, hey, this device is compromised. This device is running a rooted operating system, right? If you've rooted your phone operating system, if you put some other kind of operating system on your phone, there are ways to detect that, and there are ways to throw risk signals to make sure that you're accessing enterprise resources, that you have to do it on a standard desktop or a standard device. And so the concept of a hybrid control plane is important in that that's where we create all of the policies, right? And so everything that I've talked about in terms of the behaviors of what happens when we detect risky things in the environment, you want to create a set of policies, and that's where what the security folks, the security architects, or the security analysts have a role in doing, is that we create policy that reacts to these things that we see in the environment, and you're put there to protect everything that is on the right side of this picture when it comes to data, to our applications, to getting access to networks. All of this is protected by security policies, right? And that's where the left side meets the right side, where we accept requests to get access to something, and we make sure that there's no risk involved, and then you approve that access. And I'll get into some of the ways of how that happens. Okay, so for background, if you've ever worked, how many of you, show of hands, have developed solutions in one of the public clouds, AWS, GCP, Azure?
How about?
Okay, a couple, okay. So when you develop solutions in those environments, and especially if you do it at an enterprise level, there's a hierarchy involved in terms of when you get access to the cloud. You can think of it as an upside down tree, where the top level is where your organization creates a presence, and then everything below that top level is a way that you organize how you deploy projects or how you deploy solutions in the cloud, right? So you might have an IT branch under the top level, and there may be a developer group that's in another branch, right? Each one of those branches has different sets of security policy associated with it, and there's an example that I'll get into in a moment. But each one of the cloud environments pretty much subscribe to a hierarchy model. If you apply policy at the top level of the hierarchy, then that policy can automatically sink down to lower levels, to your groups, to your other organizations, to infrastructure that's running in your projects, right? And so being able to kind of be smart and to be strategic on how you apply security policy is important. And it's actually how you create an overall cloud security approach, is that you apply these security policies in the cloud environments consistently across all of the hierarchy. Here's an example. This is using GCP of a company, organization. And again, in their example, they have folders and projects and resources, and you can replicate these policies across any of these tiers. And each one of these cloud platforms have what they call IAM roles. And those IAM roles, those identity and access management roles, are how you get privilege access to do something. So a privilege function is, I could be an administrator that creates new users. I could be an administrator that gives users access to create other things in the cloud. So those are called privilege roles. Those are not just standard user functions. And to be able to do that, you have to kind of request access in real time to get approved to be able to administer things in the cloud. So now we bring in the identity piece of it. And in your companies, if you worked, you probably work with Active Directory. Active Directory is a service that typically, it does run in a data center or in a company environment, but most of the cloud environments integrate to Active Directory in some way. And you have to make a decision when you're integrating with the cloud on whether you're going to be doing like cloud-only access, or you're going to be integrating your on-premise company access when you access the cloud. Privilege roles, like what I just described, all of the cloud platforms have what they call an RBAC model, a role-based access control model. And how you implement those roles is critical in terms of you want to make sure that people are not over entitled to when they give. You don't want to give the entire development team, global administrator, for example, right? Because that'd be a very, very bad situation, because people who have global admin could do something wrong, could break something in the environment. I talked about user account security and being able to implement strong auth for these high privilege roles. I'll get into what passkeys are in a moment. Passkeys are kind of in my opinion, I think passkeys are one of the most significant user security improvements of the past 10 years. And really it's going to be our way to kind of move away from passwords permanently. And I talked about privilege access. There's a feature in Azure specifically called Azure Privilege Identity Management. And it kind of gives you a way to request access to things, to be able to do high privilege and administrative things, and I'll get into that. And I'll show you what an access policy looks like. Okay, demo time. Passkeys. How many of you have used passkeys? Because they've been enabled across Google, Apple, and other solutions. How many of you actually used a passkey? Cool. All right, that's good to know. So passkeys are basically a digital sign-in capability that allows you to sign into services without a password. There's a whole lot of other technology, a lot of crypto that's happening beneath the covers, but in brief, kind of that's what they are. What you may not be familiar with is the fact that not only are passkeys enabled from each of the key cloud providers, so Google and Apple have enabled them, and if you're going to use passkeys for passwordless sign-in, you have to use their password managers that come in their environments, right? You have to use the Chrome password manager if you're going to do it with Google. You have to use the Apple keychain if you're going to do it in iOS. If you use passkeys in that kind of vertical solution, it's kind of out of the box, and it'll work for you if you have devices that are all belong to those ecosystems. If you want to use passkeys across, and that's kind of horizontally, as what I'm depicting in this picture, there are other solutions out there that enable that, and those are kind of the password managers, like 1Password and like Bitwarden. And what they do is they can synchronize and allow you to use passkeys across any of these ecosystems. So let's get into demo time. Let's see if I can do this and not make a mess. I will just, let me go to my right page here. Okay, so here's GitHub, and even though I'm logging into GitHub on a web page, a lot of people may not do that, and this is going to be the most exciting demo that you see of the day. I'm going to give you that heads up right now. And so I've got passkeys enabled in my environment, so I have to unlock my, and I have to put my super secret password in. All right, keep from then yet. Let's see. Okay. Difficult enough. Okay, so what happened is 1Password, which is my password manager on my desktop, recognized that I have already saved a passkey for GitHub. And it just asked me, because I have a browser plugin, and it's pretty simple. Do you want to sign in? I say yes, I'm in. All right, so super exciting, super effective. And just think about that experience. You know, how many times do you log in things during the day, right? If you probably are doing things like saving passwords, using the same password across services. This allows you to get away from that. This is actually the bona fide way to get us to be more passwordless. Think about that experience on your mobile device. Think about not having to fumble and thumb passwords on your mobile device going forward. So there's a lot more. I could have a whole nother talk about passkeys, but the critical thing about it is that it's a strong auth method, and it's one of the ways that you can secure access to things within your enterprise, and I'll get into that in a bit. Okay, doing okay on time. Back to the prezo. So I've talked about passkeys, and let's go back now and pivot to single sign-on. So most of you in your companies, you probably sign in to your local environment, whether it's Windows, you might use Google Workspace, Google, and you might sign in with the Google identity to get access to your company resources. The idea there is that you want to be able to use your company identity to access any service that you need to work throughout the day. And so being able to do that securely is important. And if you can do that and ensure a strong authentication flow. When you access those resources, you're going to get lower risk, right? You're going to have a much lower probability of credentials being stolen, lower probability of being exposed, having your credentials being exposed on a public internet. So what I want to do then is get into another demo, and this will get into accessing Terraform, right? So I was playing with Terraform Cloud over the weekend, and I got into setting up single sign-on to Terraform. So what this is this is the Microsoft Cloud platform, and specifically this is Entra ID. And in Entra ID, I set up an application called Terraform Cloud. And when I go into set up access to Terraform Cloud, typically if you go and log into Terraform, you're just creating a local account in the Terraform, in the HashiCorp environment, right? But as an enterprise, and as a security administrator in an enterprise, you might prefer that you log into Terraform with your company credentials instead of creating a whole separate credential to get into Terraform. So that's what this is actually doing. If you go into single sign-on, SAML is a protocol that browsers understand to allow single sign-on from one service to another one. When you enable SAML, you configure Terraform to accept the SAML login. You can do things like, here's another very exciting demo where I go app to Terraform.io, gives me a page. So now, if I continue with the HCP account, I'm logging into HashiCorp with a local account credential. And if I follow this with login with SSO, and if I go with the company that I created called HomieCorp, it recognizes that, and it'll redirect me to my Azure-based login, and now I can complete the login flow with my Azure credential, which is Hotmail, of course. And now this is the next piece that I wanted to show, because you notice that it didn't ask me for a password. What it did is it asked me for completing a passwordless sign-in. And so, because it knows that my account is configured for passwordless sign-in, all it needs to know to do is it'll send a notification to my Authenticator app that I can complete here and finish that on my device to screen lock. It'll ask me I'm signed in. It'll ask me if I want to stay signed in. So there's a couple of, again, I know security demos are increasingly exciting, but the benefit there is I don't need to worry about how the user has configured logging into HashiCorp, logging in Terraform. I don't need to manage a whole set of accounts that are in the Terraform cloud. I know that our employees are accessing Terraform securely, and I know they're accessing it using strong authentications, right? So those are policies that are important to have in place, and it makes it, again, lowering risk and kind of, being in security is about managing risk, and anything that you can do that, if you can strike the balance of improving the user experience, and if you can also make things more secure, then that's where you really have a win there, right? So that's single sign-on, and that's secure single sign-on. So let's take that another level deep, and let's go within. So I don't know, you may or may not be aware that when I say Microsoft Entra, it used to be Azure AD. You may have been more familiar with the Azure Cloud, with Azure Active Directory. They rebranded it. They wanted to make it sound cooler, and their answer was call it Entra. Entra is like a Greek rooted word for enter, for entrance, right? And that's what they consider this in the cloud, right? So now, with Entra, there's also a policy administration capability, and they call it conditional access policies. With conditional access policies, on that sign-in, so that same sign-in flow, I can implement additional policies to make sure that the user is not only signed in correctly, but that they're using strong sign-in methods. So I wanted to bring this up to kind of give a sort of a hierarchy of what's considered a strong sign-in flow. On the left side, bad. On the far right side, passwordless, all good. There's varying degrees of acceptable in between them. What you're most probably used to, even in your companies today, is you get password and MFA, and you probably are using some sort of a SMS, or you might even be doing email OTP, which is kind of like 1.5 factor. But you're using one of those probably, and what's coming, which you'll start to see more and more, are these additional password methods, right? So one of the things that you'll see that are really strong password sign-in option is hardware tokens. And so on my device, I can not break anything when I do this. So this is a YubiKey. This is called a YubiKey Nano. And this is a hardware token that when inserted into my USB-C port on my computer, I could have signed in, I could have completed any of those sign-in flows just by touching on my YubiKey. There's also YubiKeys that allow you to do biometric validation, and obviously you also have the ability now to use your phone biometric as a hardware key, and things like Face ID, facial recognition on your devices, and fingerprint recognition on your devices are all valid sign-in methods because they all are supported through the kind of what's called the WebAuthn protocol. So I show all of this to say that on the right side, you see FIDO2 which is basically a MFA security standard. Those are kind of what's recommended as the most secure methods of signing into a resource. So there's Windows Hello is again, it's kind of a Windows-based operating system. If you've ever on Windows on one of your home devices, if you ever set up the facial recognition on your laptop, Windows Hello is one of the strongest ways you can sign in. On the Apple ecosystem, Face ID is that same thing. Those are the recommended ways that you should use and sign in. And additionally, what I just showed you was Authenticator app. Authenticator app is a way that you can cryptographically bind the app to your phone, and it makes your phone a trusted device to log into one of those ecosystems, right? So last thing I want to show you is a conditional access policy that takes all of that into account. And so this is where when you define a conditional access policy, you can basically use all of these parameters as part of the policy that you create. So you define what users, so if you had a group of users you wanted to target for this policy, obviously you can define that group of users and you're fine. You can actually target the policy to all of your applications or some of them. You can specify whether they're cloud apps or on-premise apps. You can target the policy to apply to only that number of applications that are running in your enterprise. So for example, when I just set up Terraform as the application that my employees log into, I add that to this policy. Another cool aspect of securing things on your networks is a network-specific policy. So what this will allow you to do is that in your enterprises, they have specific IP address ranges that your enterprise uses, right? And if you want to make sure, like if you know your clients are coming in from a particular 10 dot network or whatever, you can put that IP address range in this policy. And if someone steals a token in Kazakhstan and is trying to sign in and recognizes that they are signing in outside of the acceptable network, you can block that. So that's that's a pretty cool addition to be able to secure things using an IP address range. Other conditions that go into a policy, and these gets into risk. So now when you are signing in, and this also applies to not only when you're protecting things on your enterprise, but we can also apply this to consumer-faced logins, is if I detect the risk that I talked about earlier, if I detect user-based risk or if I detect device-based risk, I can include that and say, hey, you know what? And risk has a rating assigned to it, right? It could be high, medium, or low. It could have a score associated with it. But if I can if I recognize that I get a high risk login, or if I get a risk score that's too high, I can block it. I can force that the user use one of those strong MFA methods that I talked about earlier. I can include that into the policy and make sure that they are logged in securely when this policy gets evaluated. I can lock it down to specific platforms and locations like I talked about, and I can also lock it down to even specific MAC addresses if I wanted to, right? The policy gets pretty granular as you take it forward. And now this is the actual, the grant section of the policy where I can respond to those earlier conditions I set, and then this is where I say whether I want to block access or grant access based on these additional controls. So what I can do is I can require authentication strength, and I can require that you have to be either passwordless or phishing resistant, right? That's one of the things that I can require. There's also a concept of device management, and in your enterprises, when you come and get your computer assigned to you, that device typically is managed. It means that they monitor whatever software you put on it. They get alerts if you get a virus on your device, and if any of that ends up getting out of whack, you can block access to things because we can't let you access something on a malicious device. So I'm making sure that I am okay time-wise. Good. Okay. So all of these conditions can be brought to bear to make a fairly effective protection for whatever you access on the enterprise. And these are huge enablers. So when you're enabling your development teams, right, to do things and to write code and to push changes into your environment, you want to make sure that that they're doing this from secure logins and from secure workstations, right? It's important to make sure that that end-to-end connection that they are establishing is secure. So that is a conditional access policy. And I showed you passkeys. So I do want to cover. So machine identity is something that I don't have the time to get into the depth that it really requires. I could probably do another talk on that alone. And so machine identities are typically things like service principals. If you worked in Kubernetes before, you always are creating service principals to access and manage part of your Kubernetes environment. App IDs, client IDs are typically types of machine identities. And if you manage cloud environments, you would notice that there are many more machine IDs that get created over user accounts, right? And some estimates, it could be 45 to 1. And you really have to, and what happens is these machine IDs have passwords. And if you don't manage them as strictly as you do user accounts, and if you store passwords to a machine identity, if you store it in a repo, or if you or if you store it in a text file that's exposed somewhere, those machine IDs have as much or more privilege than user accounts do. And if they get exposed, if you go and look and kind of do sort of the audit trail of how most of the recent breaches have happened, especially things like Citibank, Microsoft breach, Okta, they all were mismanaged machine IDs where a credential to get into that environment was, in the Microsoft example, they were trying to donate some data for a machine learning, for an open source machine learning donation. The data that they ended up donating had session log information, and in those session logs were machine identities and credentials that were in the logs. Hackers got to it, found them. They were able to get into a Microsoft test environment and were able to escalate that access up into Microsoft executives' email, right? And so that those are the ways that, this innocent mistakes get blown up into real issues, right? So aggressive management of machine identities, of what they can access. And so the things that you need to do, you have to make sure you catalog them. You have to make sure that the keys, the passwords, anything that is used to secure them gets rotated. You have to make sure that you're implementing the least privilege concepts that I talked about earlier. And when you create and assign people to machine identity, you have to make sure that they have a limited time rotation on them, right? You can't just let them hang out there forever without making sure that they're being used and they're effectively being managed in the environment. So the example that I wanted to get into that, because my Terraform skills aren't quite up to snuff yet, is how you use machine identities in a dynamic way when you're provisioning new infrastructure. So Terraform, if you're not familiar, is a product that kind of allows you to create infrastructure as code. And so you write basically Terraform code, and it will create an entire solution. In the cloud, it'll create a Kubernetes environment or a web service environment or whatever you need. And so Terraform basically will execute the creation of that code on your behalf. But when it does that, it needs a machine identity. It needs a service principal. And so you can configure Terraform to not have to have a persistent access when it creates your infrastructure. So you can basically use another product called HashiCorp Vault. Vault allows you to dynamically issue a service principal in the cloud that can allow your code to run, create all of its infrastructure, and then it destroys that actual service principal. So it doesn't exist anymore, and that access that was created, it could be damaging if somebody got access to it. It goes away, right? And so that's a efficient way of using machine identities to provision your infrastructure, and then you don't have to worry about assigning a lot of extraneous privilege out there to be able to allow that to happen. So that's about it. I'm going to give a few minutes for questions. Cloud security is really a broad topic, and hopefully this gives you an overview of kind of what's really hot and what's happening in terms of how enterprises are securing cloud resources. And I'll take a few questions.
Okay. To be part of the my personal lesson, so that I talk about API keys, about storage and looking at environments with a
Define the environment. Where in the environment?
well, I guess a lot for API key to environment and then if I start API key to the environment, then it's ignore that part because that's like that'll mess up.
Yeah, the recommended way of doing it, and there are a few ways to go about that, is actually use a vault, right? And so in Azure, there's a Key Vault. HashiCorp has their Vault product, where basically you can automate into your provisioning code that provisions your infrastructure. That key is there, and then you reference that key with variables in your provisioning code. So that's kind of the recommended way of doing it. So you don't have to store it in your code anywhere. It's in the vault, and the only way that you can get that code, that key out of the vault, is that when your pipeline runs.
All right. And is it as accessible set up like Haskell's? So like any little app just to the string where you last.
Yeah, I didn't get into as much detail around that. The answer is yes. And all of the major platforms support passkeys now. And for example, like if you're developing a React or a Vue.js or whatever kind of front end technology you're using to develop your app, you can configure that and develop your app to kind of defer authentication to the cloud service, right? And so you would, in the example I just showed you where I logged into Terraform and it recognized that I need to go to Azure to sign this person in. You can configure your app to do the same thing. Once you do that, then you can set up the cloud service to enforce passkeys, right? And then it'll allow the user to save it in their browser.
Okay. So, how do you had or shut cut off to some of passwords? You had the key, the Windows alone, and then the security key. You asked me to tip about what exactly is that? How they spend
So certificates are basically digital representations of, think of it as a software-based key. They're kind of the more legacy method of highly securing access to things. And so typically when you're deploying a new server in the environment, I'll install a certificate on that server, and you have to be validated with that certificate in order to access that server, right? And so browsers use certificates a lot to be able to connect to servers on the internet, right? And so that's a way of ensuring that when I access something from my browser, there's a certificate validation that happens and that you're making that connection securely.
Sweet.
Any other questions? I am right on 45 minutes, so it's about the second time in my lifetime that I've finished something on time. So I appreciate everyone's participation here.
Thank you.